If I asked you right now, honestly, how are you doing? What are the odds that your answer would be some variation of, I feel completely fried? I mean, it's basically become the universal greeting of the modern era at this point, right? We say, I'm burned out constantly, but usually when we say that, we're using it as a metaphor. It's shorthand for, I'm tired, or I'm annoyed with my boss, or I really just need a 3-day weekend. We treat it as an emotional state or a mood, something that a good night's sleep is supposed to fix. But there's a mountain of neuroscience research that suggests that we are dangerously and maybe even catastrophically wrong about that. Because despite what you've been told by so-called wellness experts on social media, it turns out that burnout is not just a feeling or a willpower issue. It's a distinct physiological condition that is physically altering the structure of our brains. And trust me, I know that brain damage is a really heavy phrase to throw around. I know it sounds like clickbait. But when you look at the neurobiological evidence, that is effectively what we're seeing. We're talking about cortical thinning, enlarged alarm centers in the brain, severed neural connections. It's a very specific form of neural injury. But before you have a full-blown panic attack and go turn this video off to go hide under a blanket, we also have plenty of neurobiological evidence that burnout is reversible. Because thankfully, the brain is plastic, it's changeable. It can break, yes, but it can also be repaired. Hi, my name is Josh from Excellencism, and in this video, I'm going to walk you through exactly what burnout physiologically does to the hardware in your head, the mechanisms, the structural changes, and the wiring failures. Now, before anything else, it's crucial to acknowledge that many so-called productivity and wellness gurus out there have failed us in this area because they treat burnout as a psychological mood rather than a clinical injury. They tell us that the fix is to change our organizational culture, or to blame our boss, or to unclutter our desks. And while those elements might feed the problem, waiting for our corporate Slack policy to change won't help us to regrow our brains today. And then you've got the passive wellness crowd, the ones telling you to take micro breaks or a week-long vacation to reset. But here's the truth. Passive rest is a defensive move. Yes, it temporarily stops the immediate flood of stress hormones, but it does absolutely nothing to repair the structural damage that has already occurred. And this is why you feel better on Sunday afternoon, only to have a total neurological collapse back into stress and overwhelm the moment that you log back in on Monday morning. Because you can't permanently cure a structural brain injury with passive rest. You need a protocol that actively triggers neuroplasticity. So let's start at the scene of the crime. Why and how does work stress physically reshape the brain? And to understand that, we really have to go back to the beginning. We have to talk about the mismatch between our ancient biology and our modern environment. Picture this, it's 50,000 years ago, you're living on the savannah, and you see a lion. Your brain immediately triggers its fight, flight, or freeze stress response. It dumps this massive flood of chemicals into your system, cortisol and catecholamines like dopamine, epinephrine, and norepinephrine. And this chemical flood has one single purpose, which is to keep you alive. It's basically nature's performance-enhancing drug cocktail. You run faster, you hit harder, and you feel less pain. And here's the key point. Once you escape the lion, assuming you do, you're safe. The threat is physically gone. So your body metabolizes those chemicals, your heart rate drops back down, and your body returns to its baseline. You relax, and the cycle is able to complete itself. But today, unfortunately, for most of us, the lion isn't a lion. It's an email or a Slack notification or a weekly report that's due. It's a meeting with your toxic boss who constantly criticizes you. And the fundamental problem is that this modern lion never actually goes away. It lives in your pocket on your phone. It sits on your nightstand. So your brain and your body never get that return to baseline. The chemical stress response that evolution designed to be a really short, intense burst becomes a chronic low-grade flood. And it's that constant steady drip of fight, flight, or freeze chemicals that causes the actual brain damage from burnout. The brain literally switches control centers. See, under acute stress, high levels of those catecholamines that we mentioned, the dopamine and the adrenaline, open up potassium channels in the brain cells of the prefrontal cortex. And you can think of the prefrontal cortex, or the PFC, as the CEO of our brain. It's the part of our brain that's responsible for planning, impulse control, rational thought, and working memory. So when those potassium channels open, they physically stop the neurons in the PFC from firing effectively. It essentially takes the prefrontal cortex offline. And temporarily shutting down the brain's CEO makes perfect sense from an evolutionary perspective. If a lion is actively chasing you, you don't want to be pondering philosophy or making a 5-year strategic plan in that moment. You just want your body's resources to immediately react, right? So the brain switches control from the slow, thoughtful CEO, the prefrontal cortex, to the primitive reflexive centers, the amygdala and the basal ganglia. The CEO gets locked out of the room and the body's panic button takes over. Unfortunately, however, with burnout, this panic switch gets stuck in the on position because the stress never stops. The brain is just constantly bathed in these fight, flight, or freeze chemicals. And the result is that you end up in this state of what's called hypofrontality. The prefrontal cortex is chronically weakened, so you're sitting at your desk trying to do complex work like strategizing, writing, or coding, but the part of your brain that was biologically designed to do that work has been chemically powered down. So that feeling when you're staring at a screen for 3 hours, when you know exactly what you need to do, but you just can't do it, it's not a lack of willpower. The hardware is literally offline. It's a physiological blockage. And if this state persists for long enough, it stops being just chemical. It starts becoming structural. The brain actually changes its physical shape to adapt to these constant perceived threats. Now, if this clinical breakdown of what's happening inside your head is the first thing that has actually made sense to you in months, then you're in the right place. Because we don't do soft wellness here. We do excellencism, high performance through the lens of proven neuroscience. So if you want to stop the cycle of exhaustion and start the process of actual neural restoration, hit that subscribe button and join our community of professionals who are rebuilding their executive capacities together. Okay, now back to the 3 specific parts of our brain that get hit the hardest by burnout. Number 1 is the amygdala, the alarm bell or fear center of our brain. MRI studies from neuroscience research show that in chronic burnout, the amygdala experiences hypertrophy. It gets physically bigger. The chronic stress causes what scientists call exuberant dendritic growth, which basically means that the neurons in the amygdala are sprouting more connections. It's like your body's home security system is constantly upgrading itself to be louder, more sensitive to perceived threats, and have way more motion detectors. And the result? You become hyper-reactive to everything. You drop a pen and you feel a massive surge of frustration. Or you get a mildly critical email, something that normally wouldn't bother you on a good day, and you completely spiral into a panic attack because the threshold for what your brain considers a threat has just dropped to the floor. And the second part of the brain that gets physically reshaped by chronic burnout is the prefrontal cortex, our CEO. While the amygdala is growing in size, the prefrontal cortex is actually shrinking. We see cortical thinning and a loss of gray matter volume. Specifically, we see this shrinkage in the dorsal region of the PFC, which handles logic, and in the ventromedial region of the PFC, which handles emotional regulation. And the key takeaway here is that we are literally losing our brain's ability to hit the brakes on our body's stress response. See, one of the prefrontal cortex's main jobs is to regulate the amygdala. The PFC is the part of our brain that normally is able to say, hey, that email isn't a lion. You can calm down because we can handle this. But in burnout, the high cortisol and inflammatory cytokines literally prune the dendritic spines in the PFC. They physically strip away the neural connections, so the brakes wear out. And this perpetuates a vicious cycle. The threat alarm gets louder because the amygdala is physically growing, and the person whose job it is to quiet the alarm, the PFC, gets weaker because it's physically shrinking. And this leads directly to that terrifying feeling of being unable to down-regulate ourselves. Rationally, you know that you shouldn't be this stressed out, but you physically can't calm yourself down because the circuitry that connects your logical brain to your emotional brain is degraded. Now, moving on to the third part of the brain physically altered by burnout, the basal ganglia, the motivation engine of the brain. And this one really hit home for me because it addresses probably the biggest myth about burnout, that it's just laziness or a willpower problem. See, the neuroscience shows that burnout causes significant atrophy shrinkage in the caudate nucleus and the putamen regions of the basal ganglia. These are the parts that control the brain's cost-benefit analysis of doing any work. And this is so critical for people to understand. Every single time that you face a task, whether it's writing a complex report or literally just washing your coffee cup, your basal ganglia runs a lightning-fast unconscious calculation of, is this worth it? Is the expected reward from this task worth the effort that I'm going to have to put in order to accomplish it? And when the caudate nucleus and putamen regions of the basal ganglia shrink due to burnout, that calculation completely breaks down. The constant flood of cortisol and catecholamines dampens the basal ganglia's dopamine D2 receptors, making it more difficult for this region of our brain to accurately gauge the reward portion of its cost-benefit analysis. Essentially, the basal ganglia loses some of its capacity to properly process dopamine, the brain's motivation hormone, which erodes its ability to accurately calculate the benefit portion of the cost-benefit analysis. And the result is that effort feels biologically more expensive to the brain. Even incredibly small tasks can feel overwhelmingly exhausting. Answering one email can feel like climbing a mountain. But it's really important to understand this. It's not that you don't want to do the task. It's not that you have a bad attitude or that you're lazy. It's that your brain's dopamine signaling that usually turbocharges and greases the wheels of action is degraded. This causes the cognitive drag or the profound emotional exhaustion that so commonly defines burnout. Essentially, it's a fuel injection problem, not a driver problem. You're pressing the gas pedal to the floor, but the engine is sputtering because no fuel is able to get to the engine. And hopefully this offers a huge validation for any of you who've been beating yourselves up for feeling unproductive. You're trying to drive a car with no gas. Now, hearing all of this hopefully really drives home the point that this is a very real biological problem with very real biological ramifications. If you're watching this right now and you feel broken, if you feel that crushing cost of effort dragging you down every day, or you have this hyper-reactive alarm bell ringing constantly, you need to know that this isn't a character flaw. You aren't weak, you aren't lazy, you have a physiological neural injury that's actually visible on an MRI machine. Your amygdala has grown in size, your PFC has thinned, and your brain's functional connectivity has degraded. And just like a broken bone, your brain needs time and the right treatment protocol to heal itself. You wouldn't try to run a marathon on a shattered leg, but we expect ourselves to work 60-hour weeks with a broken executive function all the time. So if you're tired of suffering from chronic burnout, and you want a simple, action-oriented plan to heal your brain that is grounded in proven neuroscience rather than wellness industry nonsense, click the link in the description below to download our free worksheet, the Burnout Recovery Protocol. Thanks so much for taking this deep dive into the science with me. If you found it helpful, let me know in the comments below. As always, take care of your brains out there, and I'll see you in the next video.